Impulse. So we have a new quantity in this chapter which is known as impulse. So how do we define impulse? The change in momentum. So there are plenty of ways you can express the change in momentum. For example, change in momentum would be represented by delta p, and that would be equal to final momentum minus initial momentum. This is how we can define, or this is how we can state the change in momentum. That would be final momentum minus initial momentum. And you can also write it this way: change in momentum goes to final momentum. Mv is the final momentum minus mu is the initial momentum. And there's also another expression: impulse or change in momentum equals the resultant force times the time of collision, or the time of the impact. This is a very short instant of time, interval of time. It is represented by delta t. And matter of fact, this is the same as the definition of resultant force. F resultant equals to force equals to the rate of change of momentum. So it's just the same thing. So this is how we can find the change in momentum. And the change in momentum would be known as impulse. So the thing is, in many of the question, if an object comes to a stop, if an object is brought to a rest, if an object comes to rest, then the final momentum would be zero. So the change in momentum in that case, because this thing would be zero, so the change in momentum would be equal to minus whatever the initial momentum was. So it would be same as the initial momentum if you ignore the negative sign, because you don't have to memorize the sign convention for momentum. It's not part of your syllabus. Likewise, if an object was initially at rest, if the object was initially at rest, then the change in momentum would be equal to the final momentum, because the value of pi, the initial momentum, would now be zero. Now, last but not the least, the most important pointer probably from this topic is the law of conservation of momentum. So the total momentum of an isolated system remains constant. And then you can define this thing also. What is the isolated system? It is a system in which there is no external force. So if there are two objects are there, the two objects should be interacting with each other only. There should not be any third force from the outside. So isolated system would be defined as a system in which there is no external force. So we also have a mathematical expression for this, for the law of conservation of momentum. What you guys do is you have to put momentum, total momentum before collision. This is how you use this law. Total momentum before collision. You put this thing equal to the total momentum after the collision. So total momentum before collision would be equal to total momentum after collision. How do we find it? I'll explain in the questions. Then the last two things. Whenever there is collision, the collision could be elastic or it could be inelastic. Now, what is the difference between these two? They ask you for 2 marks. So, elastic collision is the one in which no change in kinetic energy occurs. So, the kinetic energy before and after collision remains the same. So, what do we do in this one? The engine of an unpowered a toy train is rolling at a constant speed on a level track as shown in figure 3.1. The engine collides, so there is a collision with a stationary toy truck. So we know the initial velocity of this truck is zero. Initially, its velocity is zero for the truck. Before the collision, the toy engine is traveling at a speed of 0.32 meter per second. The mass of the engine is this much. Calculate the momentum of the toy engine before the collision. So momentum of the engine equals to product of mass of the engine times the speed of the engine. What is the mass of the engine? 0.50. What is the speed of the engine? 0.32. Let's hit it on the calculator. Yeah, it should be half of it. 0.18 kg m s minus 1 or meter per second m slash s. But generally the unit is given now with the answers, unless you have to make some conversions. So this is the important question, the part B, which is related to the law of conservation of momentum or the principle of conservation of momentum. So this is the important one, and that's why it is for 3 marks. Calculate the speed of the joint engine and the truck immediately after the collision. So let me give you the situation. Before the collision, they look something like this. The engine was moving and it was moving with a speed of 0.32 meter per second. It was moving that much speed. It's just a toy. And what happened after collision was this engine and the stationary truck, these two combined after the collision. The engine now combines with the stationary truck, and now they'll be moving as a single unit. So this is the truck. They'll be traveling with a single traveling as a single unit. So what is the speed by which they are traveling now? We need to find it. So let's see what we have. The initial momentum is should be equal to the final momentum. So total momentum before collision, before the collision equals the total momentum after the collision. So the total momentum before the collision equals the total momentum after the collision. Now, what was the total momentum before the collision? That was just the momentum of the engine. Technically, it should have been the momentum of engine plus the momentum of the truck. But the thing is, even if you add the momentum of the truck, which is just zero because the truck was stationary initially, so it won't make any difference. So the initial momentum before collision is momentum of the engine, which is 0.81, sorry, 0.18. Sorry, my bad, it should be 0.16, which is 0.16 plus the momentum of the truck, which is 0, equals to total momentum after the collision. So after the collision, they now look something like this. They look as a single object which is joined together. They look as a single unit. Now, what is the mass of this unit? The mass of this unit would be 0.50 plus 0.30. So the total mass is 0.80. You multiply it by the speed of it, so you get the total momentum. Because momentum equals to the product of mass and speed. So what is the mass? 0.80. The collective mass. What is the collective speed? We don't know. We need to find that. So V needs to be found out. So all we got to do is to simplify this thing. 0.16 plus 0, just the same, 0.16 as it is, divided by 0.80. So let us write it on the calculator if we can. Point 0.16 divided by 0.8. We get 0.20. Into SF would be 0.20 meter per second. You can write it this way or this way. By the way, the units would be there. So after the collision, they are moving together with the speed of 0.20 meter per second.